Sometimes you build machine learning model with outstanding results. However, their decisions are just useless. In this video, I will show you how machine learning models with high predictive performance can be just garbage and what can you do to solve it. Hi, welcome to another AI Shot. I am Kelwin Fernandes, father of one boy, one dog, and hundreds of machine learning models. And in this video, I will show you how two of those models failed to succeed on their actual goal, which was providing good support for decision making. Okay, so here the issue is that they had like a very high accuracy, but then their predictions were just useless. They were not supporting the decision makers. I will tell you why in a minute. So the first example was a recommender system that we were building, and the idea was, for each customer, let's try to predict their customer lifetime value. How much will they spend in the next 2, 3, 6 months, let's say, giving a commercial offer. So for John, how much will he spend in the next 3 months if I send him an offer for this package for 20% discount, for 10% discount, or if I show him this bundle, okay? And the model had like a super high predictive performance, like 90-something correlation with the future expense ratio of the customer. The main issue is that the model was only looking at the past behavior of the client. It was not looking at all at the commercial offer. So the model was just saying, you know what, people don't tend to spend a lot of money, they will just keep spending a lot of money, and people that are not using the product, they won't use the product anymore. So it was super correlated, but then if I was looking at John and facing him against 3 or 4 offers, the model was predicting just the same value because it was not looking at all at the offers. The same example, the same case happened in another project where we had to price a certain asset, to maximize expected value that we receive out of that offer, out of that asset. And in this case, the asset can be whatever you want, a house, a car, a stock option, whatever. No, it's just an asset, okay? And again, the problem here is that the model was like super accurate with the end result, with the probability of being sold, but the model was just looking at seasonality on the market, like if a high demand period or not, and to the product itself. So is this house like nice, in terms of the features the house had, and not so much about the price itself, which was the variable that we wanted to control, so we could actually price the house in a way that maximized our return. Okay, so these two were like very nice examples of this concept. Like the predictions were super high, the predictive performance was super high, but then in terms of decision making, for example, if I change the price of the asset, it was just predicting the same value. So there is this design pattern in machine learning, which is building a model that will tell you how will X react to Y. For example, how will this user react to this commercial offer? How will this house sell if I put the price on this amount? Or how will John react to this treatment? Let's say John has a certain disease and you want to know if he will survive more or less if we apply a certain treatment. And the problem with these models is that they are only looking at X, okay? They are not getting, changes by the Y, okay? So this is what I call models with high accuracy but low support in terms of decision making. By the way, if you don't know how to move from predictions to decisions, you just have a link on the description for our data and methodology. Just take a look at it. So what to do if you are in this situation where you have this fancy model with a very high predictive performance and low decision support? Well, from a business point of view, even if you're not aware of it, you always need to check for how elastic is your model to the variables you want to control. So what is the elasticity? How much does the model predictions fluctuate if you change the variables you want to control? Let's say you will control, the number of rooms in the house, for example, because you want to decide if you will build a new room or not. If you change the number of rooms and the price, for example, doesn't change, then there is something there, okay? And you need to corroborate this with your team, with your technical team. So the first thing here is for sure checking for the elasticity of your model. So, and the second one you need to check is how does your model react? So if your model is reacting in the way you expect, let's say you increase the price, you are expected to see the demand increase. If you see the opposite, it doesn't necessarily mean it's wrong, because sometimes people react in the opposite way that we will expect, but there is something there, okay? So check for elasticity as your technical team, your team of data scientists or analysts to show you the performance of the model, how much the model reacts if you change the variables that you want to control. And the other one is in which direction the model changes its decisions. Okay, now let's say you are on a technical team. You are not on the business side, you are just implementing this model, and you're faced with this reality that the model is just not reacting at all to these control variables. What can you do? The first thing is, of course, regularizing the model. If you're on the business side, do not, get worried about this term. Your technical team will know what this means. Just regularize your model or adjust the model architecture, like imposing some constraints like monotonicity or whatever. Just, look at the model, especially with regularization. The second thing you can do is removing some variables that are highly correlated with your control variables, but that you cannot control. For example, let me just give you an example. Let's say price and demand. Okay, let's say you are predicting flight tickets, okay, the price of a flight ticket. And how will the demand react to that? So if I put the price of a ticket in $100, how many bookings will I have in the next month? Okay, so check on this. If I increase the price, typically this happens on high peak seasons, right? On high demand seasons, like in summer, during the summer. So the model can understand that on summer you will have higher demand and just ignore the price component, okay? However, high price and being on summer are just, very correlated, because you never apply, like a high price on winter, or on off-peak, off-season, So what you can do here is removing the seasonality, like the calendar, the date from the equation. I know your model performance will get hurt. I mean, in terms of predictive performance, you will maybe drop, from a correlation of 0.9 to a correlation of 0.7. As long as your model becomes more elastic, you are actually winning on this, okay? So remove those variables that are very correlated from the X with the variables on the Y, the ones you want to control. Remember, how will X react to Y? Just make sure your model is looking and being affected by variables on the Y. And the third thing you can do is just change the target. For example, if you're doing classification, maybe try to look at ranking, which one of these two will be a better offer. Okay, so these are the three things: regularize your model, remove variables that are highly correlated with variables on the control, and change the target, okay, for another one that is less sensitive to this kind of information. Again, tell me in the comments if this is a problem that you have faced in the past and what do you do to solve it. And if you like this concept of accurate models that are actually garbage, I have another video up here that you can click where I will show you the opposite, an actual mediocre model that can be actually very useful. If you like this video, just click around there, like, subscribe, add your comments, and activate the notifications. Take care, guys. Bye bye.